In this video, we're going to start discussing the stimulus side of electrical measurements by talking about function generators and power supplies. Power supplies are devices that output constant voltages, and on the left you can see a picture of one of the power supplies in our lab. This type of power supply has three outputs, plus 6 volts, plus 20 volts, and minus 20 volts. So it's cleverly named a triple output power supply. These outputs are actually isolated from earth ground and they're referenced to COM by default. So that COM is usually going to be the ground on your circuit. If you need to connect up to earth ground, it's available on this black port, which means you can unisolate your voltage signals if you want. And removing that isolation sometimes has noise benefits. This knob adjusts the 6 volt power supply, this knob adjusts the 20 volt power supply, and this knob adjusts something called the tracking ratio, which indirectly sets the voltage coming out of the negative 20 volt supply. Specifically, the voltage coming out of the minus 20 volt port is equal to the tracking ratio times the voltage coming out of the plus 20 volt part. And that relationship is captured by this equation in the upper right. You usually connect to the power supply with banana clips that are pictured here, but BNC cables and gator clips work just fine. Just make sure that you don't hook up a power supply with long, narrow pieces of wire pulled off of sort of the wire spools in lab, just because that's likely to cause noise and stability problems in your circuit. Power supplies are supposed to put out the same voltage no matter how much current gets pulled out of them. So the equivalent circuit for power supplies, which is pictured here, just has zero output impedance. It's a bunch of voltage sources that produce different voltages, which are all hooked together and referenced against COM. That means it's quite difficult to load power supplies, and you'll probably only ever see the output voltage start to droop or observe loading effects on it if you have a short circuit somewhere. Those shorts are indicated by high current readings on your power supply and often by flashing LED on the front of it. I've mentioned a couple of times that the output voltages of the power supply are referenced against the COM port, and that's clearly indicated in this equivalent circuit because the voltage sources are connected to COM and earth ground is just sort of hanging out on the earth ground symbol port. The fact the supplies are isolated from earth ground is really pretty convenient because it means that you can connect two power supplies in series to make really big voltage source. You can actually use two of them in lab to make 80 volts. However, if noise is sneaking in through an earth ground path, then connecting every earth ground in your circuit, including the one in your power supply, together can reduce your total noise. Usually it's safe though just to leave the earth ground port unconnected. The other kind of stimulus that's really common for us to use is a signal generator. And I'm starting our discussion of that by showing you a picture of a signal generator you haven't seen before. This is a picture of a signal generator benchtop instrument. This is actually how most signal generators in the world exist, as separate tools that hang out on your bench. And in fact, that used to be the case in our labs as well. We don't use these signal generators too often, even though they're still in the stock room. But I wanted to show it, one, to emphasize that a signal generator is a standalone piece of equipment, different from an oscilloscope. And two, because this signal generator has a bunch of really expressive buttons on the front that show its capabilities. You can make lots of different shapes of wave, you can generate noise, you can modulate your waves, which is pretty cool. You connect to signal generators with BNC cables, often with the hook connectors on the other end. And you should remember that it's a really bad habit to use these BNC cables for oscilloscope inputs. It's an even worse habit to use oscilloscope probes for signal generator outputs. That will almost always result in a corrupted signal for you and could damage the probes. Now, although signal generators are usually standalone equipment, we're lucky enough to have some very convenient signal generators integrated inside of our oscilloscopes. So this box pictured on the left actually contains two instruments, both an oscilloscope and a function generator. The function generator output comes out of this port here, and you turn it on by pressing the wave gen button and then manipulate the output using the soft keys down here. Don't forget that you want to use BNC cables on a signal generator port, but oscilloscope probes on an oscilloscope input port. So signal generators have an output with a BNC cable. Oscilloscope ports have an input signal with an oscilloscope probe. The equivalent circuit for the signal generator is shown here. The function that you pick is generated by the voltage source Vs, and the signal generator has a 50 ohm output impedance. That means that function generators are loaded noticeably even by modest impedances. So for example, if you attach a 500 ohm resistor to the output, then your output voltage will droop almost 10% compared to Vs. Also, notice that the signal generator is referenced against earth ground, which means that it's not isolated and you need to make sure that you're not putting the ground clip of your signal generator in the middle of your circuit, only on the ground node. There's one setting on function generators that has caused so much grief for students that it's worth taking video time to discuss it. This setting is called output term, which is short for output termination. Termination is another way of saying load, so that name of the setting is hinting that it's kind of related to the load you're connected to. But the big thing you need to remember when you're messing with the output term is that it has no physical effect. It doesn't change anything in your circuit. It only changes what's displayed on your voltage. So the model stays exactly the same no matter what the output term setting is, but your function generator might report a lie if you have output term set wrong, which, needless to say, is quite confusing. There are two values for the output term setting, and those values are 50 ohm and high Z. If you're in 50 ohm mode, you're saying, I want my voltage display to show the voltage that will appear across a 50 ohm termination. Now, that's Vs over 2, because if you put 50 ohms across the Vout port, you have really bad loading, and you'll see a voltage divider that gives you a factor of 2. On the other hand, if you're in high Z mode, you're saying, I want my voltage display to show the voltage that will appear if I have an open circuit terminating my output. So if you have an open circuit here, then Vout is equal to Vs because there's no voltage divider. And so when you're in high Z mode, the voltage display shows you the value of Vs. The voltage display shows these values regardless of what's actually hooked up to your circuit. So if you're in 50 ohm mode but have nothing hooked up to your circuit, your voltage display will read Vs over 2 even though the voltage that's actually on Vout is equal to Vs. Because we almost always want to know the actual value of Vs, we almost always want to use high Z mode. Now, the next question I usually get is what's so special about 50 ohms? And that answer is actually pretty involved, and I'm eager to tell you more about it in my RF class. But the quick answer is that old-timey radio cables had a 50 ohm characteristic impedance, which means that almost all high-speed equipment has an impedance of 50 ohms. As a result, old-timey function generators all operated in 50 ohm mode. Eventually someone realized this was confusing and they created high Z mode to try to combat the confusion, but that actually only made everything worse because now there are two competing standards. But the historical aside is over. The takeaway from this is you should always use high Z mode because it behaves how you expect and shows the value of Vs on the voltage display. So to summarize the main points of the video, the equivalent circuit for a power supply is voltage sources that are referenced against COM. They're not referenced against earth ground by default, and so they're isolated. Also, function generators are voltage sources with 50 ohms of output impedance that are referenced against earth ground. Finally, make sure that you use the high Z output term mode on your function generator.